Hello students, today I am going to discuss one more point from D and F block elements. Variable oxidation states of 3D series or first transition series. In this video, I am going to explain oxidation states of 3D series or first transition series. Also, why 3D series or first transition series shows variable oxidation states we are going to discuss. Before discussing this, we will just recall the elements which are present in first transition series by recalling this sentence: Swati Vikram for conics, that is scandium, then titanium, then vanadium, then chromium, then manganese, then iron, then cobalt having atomic number 27, then nickel, then copper, and the last one zinc having atomic number 30. So these are the elements which are present in a 3D series or first transition series. The next, energies of Ns and N-1 d levels are almost same. 2 electrons in outermost cell except that chromium and copper. So lowest oxidation states may be +1 or +2. For this, we will consider two examples, that is cobalt having atomic number 27, its electronic configuration can be written as 18 argon 3d7 4s2. So here 4s has 2 electrons, so lowest oxidation state will be +2. Then chromium 24, its electronic configuration 18 argon 3d5 4s1, it has 1 electron in 4s, lowest oxidation state it possesses +1. So in this way, lowest oxidation state is +1 or +2. Next, in this table we are going to write oxidation states of each and every elements from 3D series, and then we will discuss that one by one. So scandium 18 argon 3d1 4s2 oxidation state +2 +3. Then titanium oxidation states +2 +3 +4. Then vanadium +2 +3 +4 +5. Then chromium +1 2 3 4 5 and +6. Then manganese 18 argon 3d5 4s2 +2 +3 +4 +5 +6 +7. Then iron +2 +3 +4 +5 and +6. Then cobalt +2 +3 +4 +5. Then nickel +2 +3 and +4. Then copper +1 and +2, and then the last one zinc +2. So here you will find that from scandium to manganese oxidation states increases, and then onwards to iron it will again starts to decrease. So number of variable oxidation states decreases from iron onwards. One more common observation, that chromium possesses +1 oxidation state, similarly copper. Then +7 is the higher oxidation state which is exhibited by manganese, and most common oxidation state is +2. All the elements which are present in 3D series, they mostly observed in +2 oxidation states, except that scandium, which is mostly observed or generally observed in +3 oxidation state. Now one by one we will discuss about the oxidation states of each and every element. Scandium +2 +3. So here +3 is the more stable one, as 3D becomes 0, then it forms generally compounds in this +3 oxidation state only. Then second one, titanium +2 +3 +4. +4 is the more stable one, as 3D becomes 0. Then vanadium 18 argon 3d3 4s2 +2 3 4 5. Here in this case +5 is the more stable one, as 3D is 0. So these are the first three elements. They become stable when 3D is 0. So plus 3 for scandium, plus 4 for titanium and plus 5 for vanadium are the more stable oxidation state. Similarly, we will discuss about chromium. So plus 1, plus 2, plus 3, plus 4, plus 5 and plus 6. Why plus 1 here? In 4s it has only 1 electron. So plus 1 it is there. Lowest oxidation state of the 3D series. Then next, in fact this plus 1 oxidation state is more stable as d orbital becomes exactly half filled. So when any orbital is exactly half filled or completely filled, then in that case that element will be more stable. So when chromium is in plus 1 oxidation state, 3D its capacity 10, so it is exactly half filled, 3D 5, and in plus 1 oxidation state you will find that chromium is more stable. Then salts with plus 2, we are going to call them as a chromous salt, with plus 3 chromic salt, while plus 4 and plus 5 oxidation states are comparably unstable. Then plus 6 oxidation state is very stable. K2CrO4, K2Cr2O7 are the examples of the compounds which are formed in this oxidation state. Also, it acts as a very good oxidizing agent in this plus 6 oxidation state. So that is about the chromium. Then we will discuss about manganese. Plus 2, plus 3, plus 4, plus 5, plus 6 and plus 7 are the variable oxidation states which manganese possesses. Here manganese, the plus 2 oxidation state is more stable as it has exactly half filled state of d orbital. Similarly in case of the chromium, salts with plus 2 we are going to call them as a manganese salt, while plus 3 and plus 5 oxidation states are unstable. Manganese dioxide MnO2 in its plus 4 oxidation state is very stable, and plus 7, which is the highest oxidation state for these 3D series elements, in this state it acts as a very good oxidizing agent. Example KMnO4. Then next element, iron. As we have already seen, onward to this element, the variable number of variable oxidation states, it is going to decrease. Iron possesses plus 2, plus 3, plus 4, plus 5 and plus 6 oxidation state. Salts with plus 2 we are going to call them as a ferrous, while plus 3 ferric compounds, while plus 4 and plus 5 oxidation states are less stable. In plus 6 oxidation state it is going to form K2FeO4. Then cobalt and nickel, common point which we can discuss about the cobalt and nickel, they form salts with plus 2 and plus 3 oxidation state. Plus 2 is the more stable one. Similarly in case of the copper and zinc, they exhibit plus 2 oxidation state. Copper salts, in plus 1 we are going to call them as a cuprous salt, and in plus 2 we are going to call them as a cupric salt. In this way, 3D series or first transition series elements possesses variable oxidation states which we can discuss with the help of their outer electronic configuration. Thank you.